Hello everyone, welcome to a new segment in this class. So in this segment we are going to talk about algorithm analysis. So this is a very important topic in our data structure course because uh, from now on, whenever we are going to talk about a new operation and a new algorithm, we have to know that how to analyze the algorithm. All right. So let's first see that what is an algorithm. An algorithm is a set of instructions. We are going to follow them to solve a problem. So if we have a problem, we are going to follow a set of instructions to solve them. All right. So this is known as an algorithm. Now, if we have a problem, one problem can have multiple solutions. All right. Now, for example, let's say we want to cook rice. Now, to cook rice, we know that an algorithm is a set of instruction. All right. So to cook rice, we have to follow a set of instruction in orderly fashion. Means we have to follow the orders, and we have to follow the orders of each instructions. All right. Now to cook rice, we may there can be multiple solutions. For example, we may cook rice in a rice cooker. All right. Or we may cook rice just without a rice cooker, just in a pot. All right. First boiling the water, then giving the rice in the boiling water. Now, the idea is that for a one problem, for the same problem, we might have multiple solutions. All right. Now, which solution we are going to consider for better result or better efficiency. All right. So for different solution, we have to have a way to measure the efficiency. Okay. By efficiency, how do we find the efficiency? That is actually one of the main focus of this topic. Okay. How to measure the efficiency of an algorithm. Obviously, if we have multiple solutions, we are going to pick the solution that is more efficient. All right. Now, an algorithm in computer science, an algorithm can be implemented also using multiple programming languages, or we can also implement them on different platforms. All right. Now, what is the requirement of an algorithm? The first requirement of an algorithm is that the algorithm must be correct. By correct means the algorithm must give us the correct result. All right. For example, if we want to cook rice, the final result has to be rice. All right. I mean, it doesn't matter which path we are following, the final result has to be correct. All right. For example, let's see, we are talking about sorting algorithm. Okay. Now, it doesn't matter what is the data format is. All right. If the data is already sorted, or if the data is random order, or the data has repeated elements, it doesn't matter what is the format of our data set. Our final result has to be the sorted data. All right. So one of the main focus of an algorithm is that the algorithm has to produce correct result. All right. As a computer scientist, we may have to come up with an algorithm. All right. So you have a problem, you have to actually find a solution to solve the problem. So the first requirement is that the algorithm has to produce correct result. Then we are going to think about what is the efficiency of the algorithm. And if we can find a better result, if we can find a better algorithm in terms of efficiency, obviously we are going to pick the algorithm with the better efficiency. All right. So once we have the correct algorithm for a problem, we have to determine the efficiency of the algorithm. Now the question is how to find the performance or efficiency of the algorithm. There are two aspects of algorithmic performance. So we can measure the performance of an algorithm from two perspectives, time and space. Time means, as we said, that algorithm means it's a set of instruction. Now each instruction takes time. All right. So based on the instruction we are following in an algorithm, all right, we can find the time that is taking to run the algorithm. All right. Now, based on that, we can find how fast does the algorithm perform. All right. So that is one measurement, how we can calculate the performance of an algorithm. Now, the question is what affects the runtime of an algorithm? Okay, we're going to talk about that. Another perspective is space. So data structure or the data takes space. All right. We know that when we run the algorithm, when we run a program, okay, the data set has to be fetched from the disk, from the secondary disk to the memory space. Okay, memory space means RAM. All right. Now, depending on what type of data structure we are using, all right, what type of variable we are using, depending on that, it is going to take space in the memory. All right. So here the question is what kind of data structure we are using. We may use just a static array or dynamic array or linked list, and a lot of different data structure we are going to talk about in this course. Okay. So depending on that, an algorithm is going to take space in the memory. So then in that case, we have to actually find that how do we choose a data structure that can make our algorithm more efficient. All right. Now, in this topic, we're going to mainly focus on time. All right. So we're going to mainly focus on time, means how we can estimate the time required for the algorithm. All right. And if we can estimate the time required for an algorithm, then we can think about, can we reduce the time required? For example, let's say we are cooking rice, okay, just a traditional way, and it is taking like 20 minutes. Okay. Now I'm thinking that I have to cook rice before I leave for the office. And generally in the morning, I don't get that amount of time to cook rice. All right. So if I find a way that is going to take like 5 to 10 minutes, all right, and also that is going to produce the same quality of rice. For example, like our algorithm has to produce the correct result, so it has to produce the same quality of rice. All right, so obviously I'm going to pick this way. All right, so that means first I have to know how to estimate the time required for an algorithm. Then I can think about, can I reduce the time required? Obviously, if I can reduce the time required, obviously I can say that this is a better approach. So analysis of algorithms is the area of computer science that is going to provide us a formalized, a mathematical or formal tools to analyze the efficiency of different methods of solution. The idea is that we may have different solution. All right. Now I may think like that solution A is better than B. All right. But as a computer scientist, this theorem or this statement is not enough. All right. I have to have a formal tool by which I can analyze and I can um, I can tell for surely that that the algorithm A is better than algorithm B. Okay, means algorithm A is more efficient than algorithm B. All right. So this topic is about, we're going to talk about the formal tool or mathematical tool, all right, by which we can measure the efficiency of different methods or different algorithms. All right. So how do we compare the time efficiency of two algorithms to solve the same problem? So that's one question. All right. So that's one question, and that's the most important question. Okay. Now, let's say you don't know anything about analysis of algorithm. Okay. But someone is asking you that what is the time efficiency of these two algorithms? Okay. So what is the naive approach? All right. How do I say that? How do I just say that? Let's see, I have two solutions, two algorithms. How do I say that A is better than B or B is better than A? Okay. And from now on, we're actually, when we're talking about efficiency, especially in this topic, in this chapter, we're going to focus on the efficiency in terms of time. All right. All right. Now, let's say I don't have any idea about the formal tool to measure the efficiency. Okay. But I may just want to tell which algorithm is better by implementing the algorithm. Okay. So I'm going to pick just any programming language. All right. Let's pick C++. Let's run the algorithm. I mean, let's just implement the algorithm using C++ and run these two algorithms separately. Okay. So run the problem with algorithm A and then run the same problem with algorithm B. All right. So the algorithm, there are two algorithms, okay, algorithm A and B, but the problem is same. All right. So I'm going to implement algorithm A, I'm going to implement algorithm B. All right. Using the same programming language, and let's see, run the same problem using these two algorithms. All right. Now, after I run this algorithm, what I can do actually in programming language C++ also, there are some function by which I can measure the time. All right. So I can measure the time to run the code. All right. For example, I may have a time function, like a time function at the beginning of the program, and at the end of the program I may have another time function. Okay, and I can see the difference between these two time, and I can say what was the exact runtime for a specific problem. Okay, for a specific C++ code. Now that's why I can run the same problem using two algorithms, and I can run them, and I can tell actually which algorithm is working faster. All right. All right. Seems like reasonable, but there are actually a couple of things we have to consider. All right. Now, as we said that what affects the runtime? There are multiple other factors that can affect the runtime. All right. All right. So, so in different implementation, I may use like different uh, variable declaration or different number or different type of data structure. All right. Or depending on what type of processor I'm using. All right. So what type of processor I'm using, depending on that, my runtime can be also different. So there are some other factors that can affect this runtime. All right. So the factors are means what type of computer I'm using. Okay. And what data should the program use? So when I will compare two algorithm, okay, I should not actually think about what type of implementation I did. For example, did I declare too many variables? Okay, or did I declare what type of let's say what type of processor I did use? All right. So I may use one type of processor and my friend might use another type of processor. Okay. But when I will ask my friend to when I will ask my friend that algorithm A is better, that might not be true for his case. All right. So that's why when I'm going to analyze the algorithm, I have to consider few factors. All right. So we should compare the efficiency of the algorithms independently of a particular computer. It should not be factor that what type of processor, what type of computer I'm using. All right. And analysis must be independent of specific data. All right. So what type of data I'm using, my analysis also should not be dependent on that. So analysis must be independent of what type of specific data I am using. All right. So when we are going to analyze the algorithm, we should employ some mathematical techniques, all right, that will analyze the algorithms independently of specific implementation, all right, computers or data. All right. So my analysis should not depend on how I am implementing, all right, what type of processor or what type of computer I am using, or what type of data I am using. All right. So when I'm going to analyze the algorithm, first we count the number of significant operation in a particular solution to assess the efficiency. Then we are going to express the efficiency of the algorithm using growth function. Growth function is a very important term, and we are going to know about that in detail very soon. Okay. So our algorithm, our analysis of algorithm only should depend on the size of input, or we should say the size of data set. Okay. And the growth function actually depends on the size of data set. All right. So to analyze the algorithm, we are going to count the number of significant operation. All right. Depending on the significant number of significant operation, we are going to calculate the efficiency. All right. And we're going to express the efficiency in terms of the growth function. All right. Now, the execution time of algorithms. So we know that an algorithm is a set of instruction. Okay. So each instruction or each operation in algorithm has a cost. So here cost means actually we're going to measure the cost in terms of time. All right. So each operation takes a certain of time. For example, let's say we have a operation, we have a instruction or a programming syntax like that. Count equals to count plus 1. All right. So what we are doing, we are first, here we have actually two operations. We're incrementing count with 1. Okay. And then this updated count value, incremented count value, we're assigning that to new count value. Okay. So here we are having, we can say we're having two operations, but it takes a certain amount of time. All right. But it is constant. So what does constant means? Constant means that it doesn't depend on input size. All right. So constant means it may take any amount of time, but it's constant. Means it doesn't matter what is the input size. Okay. So whenever you will run this command, it will always take a constant amount of time. Okay. There is no other factor. All right. So there is no other factor that will determine the runtime of this instruction. All right. So it doesn't matter how much time it is going to take. All right. If it doesn't depend on the input size, okay, we can say that the runtime is constant. All right. So here you can see that here we have sequence of operation. Let's say our first operation is count equals to count plus 1. Okay, so we have a count value. We are going to increment the count value and assign the value to the new count variable. Okay, so the cost is C1, means just any amount of time. Okay, any amount of time but constant. All right, then let's see, we have another instruction like that, sum equals to sum plus count. So we have a new count value. From here we're going to add this value with sum. All right, and then we're going to assign this value to new sum. So here also you can see that each of the count and sum, it has a specific value, and we're going to use that. So here also it is going to take a certain amount of time. Okay, but it's a constant value, means it doesn't depend on any other factor, specifically the input size. All right. All right, so if we have a sequence of operation like this, the runtime, we can find actually the total cost, like by adding all the cost. Okay, for example, this instruction is taking C1 time, then we have this instruction taking C2 time, so the total cost is going to be C1 plus C2. Okay, all right, so if we have any other instruction after that, let's say sum equals to sum plus 1. Okay, so this instruction will take C3 amount of time, again constant. Okay, so then total cost will be C1 plus C2 plus C3. All right, so you can see that if we have a set of operations, okay, set of operations, we know that in algorithm we are going to follow the set of instruction following the order. Okay, so each operation takes a certain amount of time, and if we have a set of operation, then the total cost is going to be the summation of the cost of each operation. Now let's see, here we have a multiple, here we have a simple if else statement. Okay, so